Hello everyone.
Space missions.
In this video we will highlight different methods and algorithms used in space missions to explore universe. We all know space missions are conducted for multiple reasons. In this video we will cover different space missions, their challenges and technologies and algorithms used. And especially we will focus on the technologies and algorithms used in space missions. But first, we will start with small introduction about space missions, how human evolve, discover tools, techniques, and step into space. So this is our journey from caveman to astronaut. Now let's start it. A long time ago, when humanity first lived on Earth, they often gazed up at the dark night sky filled with stars, and they asked one another,
What's up there, bro?
stars seems far away and nobody know what was beyond our planet.
It was the beginning of human curiosity.
But their curiosity led them far beyond the clouds. As time passed, humans start discovering their own world. First, they start learning about their surrounding with simple tools, but their thoughts always focused on the sky.
With time, they learned to map the sky.
Navigate the ocean and understand moon cycles, and start creating flying machines like airplanes. But even with all their knowledge of everything,
Huge universe above them was still a mystery.
some believed that stars were gods, others thought they were faraway lights.
But never-ending question never stops. What was out there?
By early 90s, humans discovered ways to launch rockets into the sky, getting closer and closer to the space. But still, idea of reaching outer space was still far away.
Then in 1957, something incredible happened. The Soviet Union launched Sputnik 1.
First artificial satellite was launched by Soviet Union into space.
It was the first time something made by humans reached outer space. This event made the world realize that humans have reached outer space.
This event made the world realize that human can actually travel beyond Earth.
And the space race started at this point.
Soviet Union and United States engaged in a furious battle to explore space. In 1961, Soviet Union sent first human into space. And this mission was first big step in human space exploration, and it proved not only machines but humans are capable of traveling to space.
But the goal was bigger.
They wanted to send humans to other planets in the space. In 1969, a new chapter began. United States succeed in landing human on moon. Neil Armstrong and Buzz Aldrin become the first human being to walk on moon. Apollo mission was massive achievement in human history.
It was the result of years of work, struggle, and dedication.
After moon landing, humans continued to explore space. In 1981, NASA launched Space Shuttle, which could carry astronauts into space and bring them back. In 1990, world we come together to build International Space Station, where astronauts from different countries work together and study things like how humans live in space and how to grow food in space.
Moon was not the end of space adventures. They wanted to know more about Mars, the red planet.
NASA sent robots to Mars, like Spirit and Opportunity, to take pictures and learn about surface. In 2012, NASA sent Curiosity rover. In 2021, Perseverance rover started exploring Mars to search for signs of ancient life. At the same time, private companies like SpaceX have begun developing spacecraft designed to carry humans into space, lower the cost of space travel, and make space exploration accessible to more people. We'll highlight different challenges in space mission. One by one, we will cover mission, their challenges, solutions, algorithms, and algorithm used. Here you can see three main challenges of space missions: cost, risk, and complexity. As we all know, space exploration is extremely expensive due to high tech equipments, infrastructure, experts required, hiring and training skilled scientists, engineers, astronauts, it's costly, and long timeline, as space missions often take years to plan and execute, and it increases overall cost. Second challenge, we have risk. Space missions are always risky, involve risk factors like human safety, because human space missions expose astronauts to microgravity, radiation, and sometimes risk of equipment failure, and even sometimes mission failure due to errors or unexpected conditions. Third, we have complexity. Space missions are not easy, they are highly complex because they involve interdisciplinary coordination. Designing and executing a mission required collaboration across numerous fields, including aerospace engineering, robotics, biology, material science, and other. And for successful missions from launch window to spacecraft trajectories, every aspect must be calculated with extreme accuracy because space is an unforgiving environment with unpredictable conditions such as solar storms, micrometeoroids, and shifting planetary atmospheres. So missions need to be prepared to deal with all such conditions. But over time, technical developments and international collaborations are helping to minimize these challenges. For cost issues, reusable rockets like SpaceX Falcon 9 are reducing launch cost. For risk minimization, different simulation technologies and improved spacecraft design enhance safety. And for complexity, different artificial intelligence and machine learning algorithms are used for problem solving, navigation, and autonomous decision making during mission. Space missions are highly complex, but their successful execution has the potential to transform our knowledge of the cosmos, inspire innovation, and increase global collaboration. Now we will cover different algorithms used in space missions. For space missions, different hybrid algorithms are designed. So here we cannot say that any method or algorithm is directly applied in the space mission because they develop different hybrid algorithms based on fundamental methods. They create hybrid techniques and the use of specific algorithm like ACO, genetic algorithm, PSO, A star, T star in NASA mission is often cited in research papers, technical reports, or implementation in related projects. Genetic algorithm used in optimization like evolutionary mission trajectory generator for trajectory optimization, interplanetary mission design, balancing multi-objective goals like such as fuel efficiency and mission duration and time, and PSO algorithm application in robotic navigation and antenna placement. A star and D star algorithms, they are widely recognized for pathfinding in robotics and have been used in Mars rover navigation. The Opportunity and Spirit rover use variation of grid-based pathfinding algorithms like D star. Here we cannot say that specific algorithm is directly applied in any project because they develop their own algorithms like they create hybrid technique by combining multiple methods. Done. You can see the algorithm for spacecraft path designing. Optimization algorithms are often used to solve the best route like minimize fuel, time, for example, genetic algorithm, gradient descent, and pathfinding algorithms like A star and different numerical methods simulate gravitational force and calculate orbital path for autonomous decision making. In deep space missions have delay in communication with Earth, so spacecraft use AI based algorithm to make decisions. For example, Mars rover can autonomously select their path over rocky terrain, and tiny errors can be built over millions of miles. So spacecraft make small adjustments to stay on track. They are planned with optimization algorithms, and these corrections are planned with optimization algorithms. Obstacle avoidance for lander rovers for missions that land or fly close to celestial bodies. Pathfinding ensure the spacecraft avoid obstacles, and spacecraft have different sensors to know their position. So algorithm like Kalman filter combines sensor data to calculate the spacecraft location and adjust its path if needed. And for gravity assist, spacecraft sometimes use gravity of planet or moon to speed up or change direction without using extra fuel. So here, algorithms are used to predict where the planet will be at the right time to execute this maneuver. We know that spacecraft do not travel in straight line, they move in curved path because of the gravity of planets, moons, and the sun. So engineers calculate the trajectory, minimize fuel consumption and time by using gravity assist. So algorithm like Lambert's problem solver and Kepler orbits predict the best path based on physics. So in space missions, path planning algorithms are often used for spacecraft and rovers, signal processing used for communication, optimization techniques used for trajectories, AI and machine learning for autonomous decisions, image processing for camera and telescopes, genetic algorithm and simulated handling for mirror alignment. Due to the simplicity and efficiency of PSO algorithm to find out optimal solution in high dimensional space, they are used for trajectory optimization and robotic pathfinding. And genetic algorithm used in variety of projects, especially to solve complex problems, and traditional methods either fail or they take too much time for antenna design, spacecraft trajectory optimization means here to identify best path to minimize fuel consumption, time, and other mission constraints. For planetary exploration, for robotic system optimization, for material design to discover new material with desirable properties for space mission like lightweight, high strength material and all. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video. And you can check the resources in the description.